Great. Hi, everybody. Thank you so much for joining in. For those of you who are here for the first time, my name is Dhruv, and I'm a researcher at Lossfunk, which is an independent research lab based out of Bangalore, exploring general intelligence in all its glory, like we like to say. I'm very glad to welcome you all to the opening session for Conference for AI Scientists. CAISc 2026 is a research conference that Lossfunk organized in collaboration with BITS Pilani, where the premise was to enable people and allow them to submit work that was partly or almost entirely authored with the use of AI systems. We also had an AI plus human review pipeline. And in this session, what we hope to cover is discuss how we got started, what was the conference design, share those numbers with you, talk through our review process, and more importantly, share what we learned about AI done science with all of you all. Before I hand it over to Paras, who'll be talking about the motivation, I'd also like to give a big shout out to our sponsors, Anthropic, OpenAI, and Jarvis Labs, for the folks who would be winning awards. The awards will be credits across model and compute from these three wonderful companies. We're also very grateful to the wonderful institutions represented on our steering and program committee, including NUS, IT Delhi, Triple IT Edge, IISc, and many more. Thanks to Professor Kumar and Professor Mandal for reaching out to various faculty from all over the world and get them to support us in organizing this conference. Now, with that, I'm happy to welcome Paras to talk about the motivation behind it and what got us excited. And yeah, go ahead.
Thank you so much, Joe, for setting the stage. Yeah, so I think, we are obviously entering a new era and paradigm of doing science. These days I'm just constantly left wondering what even is word science. And I think that's a very important question for everyone to reflect upon, because the whole notions of what science is, at least for me, I grew up reading biographies of Einstein, Newton, Darwin. My first pop science book was Brief History of Time. So I think science, as we sort of learned from our schools, has been really solidified as a as like a methodology, as a social structure, where humans did humans did all of it, and other humans sort of reviewed it, and it has been like a knowledge creation, knowledge gathering enterprise, and that's what I think the word science means, right? But today I think all of it is just up for redefinition, regrabs. In fact, if you've been following this whole Jacob's conjecture, I won't call it controversy, but the whole thing on Twitter, I think it has sort of split mathematicians into two fields. Some of them are saying, fields medal won't even exist, and the others ones are saying, math is literally for just understanding for humans, and if there is no understanding, there is no science. So I think we are at a very interesting point where cognitive labor is getting automated. So what is science? What is understanding? What is knowledge? What's the point of doing any of this is something we should be questioning, because the formats of, let's say, 10 years from now won't be the formats we have grown up with. Will there be journals? Will there be papers? Who will consume science? Will humans will be the major consumers of science, or will most of it will be consumed by agents? What do agents want? Will journals stop asking for papers and start asking for transcripts? We don't know. So I think it's a very exciting period, and it also is letting a lot of outsiders do science that was never possible before. So I think another interesting thing, one that I keep hearing when I sort of talk to people who are at the front of doing thinking, is that the role of human scientists actually will change from doing science to defining what you can call as like a well-defined, verifiable problem that agents can really solve. I came across someone who talked about that that now the role, let's say, if you say, for example, the level that agents are at, you can't say like build a better quantum computer or solve this quantum computing problem. I think the role will get to how do you define this problem well enough that like a swarm of 1,000 agents can very reliably sort of hill climb on that problem. So there is this shift between what scientists used to do and what scientists will do, even going forward in academia, that these agents are enabling. So And I think we've seen that these agents are now sort of reaching intern and workshop level research. I'm pretty sure Fable would reach main conference level manuscripts. So in next, let's say 1-2 years, NeurIPS, ICML, ICLR, and even top journals will be flooded by mostly AI generated or AI assisted content. Um, so would conferences even survive? I don't know. So this is all that, and we can go to the next slide. But all of this is what has been on our mind. So Dhruv Trehan from Lossfunk has been working on this for a long time. We got like a paper from Lossfunk accepted at Agents for Science conference. We wrote like this paper on why LLMs are not scientists yet. And I seeing all that, Professor Dhruv Kumar from BITS Pilani approached us whether we wanted to collaborate on doing a conference, which is just the first one where AIs are the authors. It was so intriguing that we had to say yes. This is the first time for us organizing conference, and I think first time probably for Professor Dhruv Kumar also to this scale. So I mean, we learned so much. We didn't know what organizing conference meant, but I'm happy that we joined forces and decided to do this. Uh, can we go to the next slide? Yeah, so what was our objective? I think our objective was to investigate what we suspected was probably already happening. I think we had been hearing rumors on like last year that now a lot of content, at least papers being generated, are heavily AI sort of oriented, and very few people were explicitly flagging it off. So it's very hard to detect what is human contribution, what is AI contribution. So we thought that we need to be very explicit about it and just try to see how far the systems have come. So we thought that we'll just take this as a basis and say even authors are AIs and viewers are AI. I know it sounded really wild, but I think it turned out well. And this is like a meta science experiment for us, because through this conference we were able to investigate, and I think in the rest of the presentation you will see some data on how did different AI assistants panned out in terms of its correlation with quality. But we wanted to see how far AI review systems have come about, how far this AI systems have come about in both open-ended and verifiable problems. And mostly, I think we were interested in how do we bring more attention to what we suspect will be the main trend going forward. So this just has enabled us to gather an initial community, which I'm hoping will snowball into defining what science of the future looks like. So for the rest of our presentation, I'll give it to Professor Dhruv Kumar to talk about how we actually did it and what we found out.
Sure. Thanks a lot, Paras. And thanks a lot, Dhruv, for introducing the conference. So let's see. So as Paras mentioned, I think obviously in India, this is the first attempt to do a conference like this. But I think the core idea was already existing. We had this conference, Agents for Science, which Paras also mentioned. Lossfunk had a couple of papers there. So this was a conference conducted by some folks at Stanford University. So they had also done this AI. Authors are also AI, reviewers are also AI. So we took that seed idea from this Agents for Science conference and expanded it into two tracks. Number one, the verifiable problem track. So there, this track, as the name suggests, the problem should be, so if we pose a problem to anyone and either a human or an agent gives us the solution, we should be able to verify the solution autonomously in a deterministic way. So that was this verifiable problem track, and this was actually specifically proposed by Paras and team. And the motivation was that, and you must be seeing in this in media, the more precise the problem statement is, and the easier it is to verify a solution. I think AI agents bloom, and they do very well when something can be deterministically verified. So I think Siddharth from Lossfunk and worked with Dhruv and Dhruv T and some domain experts to prepare a list of, I think, around 4, 5, up to 6, 7 problem statements in this verifiable problem track. And the other idea was that we also wanted to encourage undergraduates in India to take up this kind of research and explore Cloud Codex doing this autonomous research. So we wanted to keep the problem simple enough that even undergraduates can take a shot at solving these problems with the help of course, these AI agents. And the second track, of course, was the standard paper submission track, which we see in any conference. So here, the authors can propose any problem statement, use any methodology, and evaluate it in whichever way is reasonable. So this was open-ended, and of course, I think this is a good. This kind of conference design would also help us to basically see like where AI agents are working well and what kind of verification validation they can do well and where they are lacking and so on. So more on it a bit later. So I think interestingly, I think we got fortunately 200 plus submissions, and I still recall. I think it happens with almost all conferences that we receive most of the submissions in the last 2, 3 days, 4 days. So I think I still remember 3, 4, 5 days before the conference, we were looking at the open review dashboard, and we hardly had like I think maybe 20 or 30 submissions, and then we were just wondering how many submissions which we'll receive. But yeah, fortunately, I think we were fortunate enough to receive 200 plus submissions. Expected, yeah, I think as Paras mentioned, Dhruv was super worried, and expectedly, I think majority of the submissions were from India. And once I think as the stat share says 75, around 75% of the submissions were from India, and 25% were from outside India, which is also a reasonable number, I would say. Uh, Having been part of other conferences and having seen that the participant demographics in other conferences hosted within India. So our total number of submissions were 200 plus. Some were withdrawn, handful of them. Some of them were desk rejected because of formatting, some other issues, the usual ones. And then acceptance rates. In terms of acceptance rates, I think we'll talk about the review process in a bit, but the high level numbers were around 40% acceptance rate, right? And in track one, we had a slightly higher acceptance rate and of about 65%. And track two, we had again 39-40% acceptance rate. So these were some of the statistics. And so yeah, now coming to so now I'll spend some time on the review process which we undertook. So I think, of course, many AI reviewers exist in the world. I think some of them are open source as well. Majority of them are not actually. And so we had actually Professor Mandar and myself had actually worked on the AI reviewer as part of our last year's EMNLP paper. So we had some idea how to go about doing this review process using AI. So we used that experience and worked with a couple of undergraduate students at BITS Pilani. So I think Shashank is there. Shashank, maybe you can say hi on the chat. Shashank is there. Shashank and Devansh, final year undergrads at BITS Pilani. I think they did most of the heavyweight lifting for building this reviewer. And we followed the, you can say so, quote unquote, the standard agentic pipeline where you basically generate some initial stuff and then you try to verify it using a loop, and then you basically finally emit or generate the verified stuff. We used frontier models. So we were, of course, I think Lossfunk was generous enough to support the development of the AI reviewer. So we used frontier models, Opus, GPT, DeepSeek. I'll come back to this, Y3 models. And as you can see on the right-hand side, I think the pipeline was, you can say, simple in one sense. So you basically take as input the PDF which the authors have uploaded along with any supplementary material, make the model read the submission, extract claims. So whatever claims the paper is making, and then we essentially kind of try to gather evidence for each and every claim. So evidence is basically of two types. One, the paper itself is claiming or mentioning in the paper, and then second is of course the existing work. So let's say if the paper is saying this is like the first attempt at solving this problem. So gathering evidence would involve going through the web, finding out the relevant literature, and verifying whether this is actually the first attempt or not the first attempt, right? So therefore, we had this EXA web search service, which was used to basically make sure that all our findings, analysis, or review is grounded in the existing literature. And that's what we expect from a human reviewer also, right? The human reviewer is expected to be have some knowledge about the domain in which the paper is, and they should be able to compare or evaluate the paper in terms of what is already existing out there. So this was important step. And the other thing was, I think, around these tables and figures. Of course, nowadays these frontier models are good at reading tables, figures, but we did of course, but they do still make mistakes, and we'll talk about it a bit more later. So what we did was we had like two steps. Essentially, we had some redundancy in the sense that we were extracting the tables and figures using the PDF extraction library, whichever we were using, and also we were using a multimodal foundation model or visual language model, which can basically look at the table, look at the figure, and interpret what it means, look at the graph. Our AI review, I think AI reviewer, I think I'll talk about it a bit more, but we had of course, this was the first time we were conducting this conference, and so we wanted to keep a slightly we obviously didn't want to keep ICML, Newer IPS, or ICLR level of acceptance or rigor. So we thought, I think, workshop level at a core A-star conference like ICLR, ICML, that would be a good starting point for us. And of course, we'll talk about it a bit more. But so considering that, and our review criteria were around these four things. The paper should contain at least something new, which is worth sharing and discussing in the broader scientific community. Whatever claims the paper is making, they should be supported, verified to some extent at least, and by the rest of the paper. And it should not have the obvious inconsistencies, contradictions among the different sections. For example, abstract is saying 20% performance improvement, but the evaluation section is actually saying 15%. So these simple inconsistencies should not be there, because these are kind of indicative of that the authors have not done a great job at even going through the manuscript once end to end. And finally, the most important one, which is catching a lot of attention these days in the media, references and citations should not be hallucinated, which is the biggest complaint we have about any frontier model or AI agent these days. So I think on the right-hand side, you can see like the summary of the system prompt which we had given to our AI reviewers. Right. So I think it talks about those 4 or 5 criterias, and then rating was simple, accept or reject. And then confidence, of course, we had confidence also, how confident the AI reviewer is in terms of making the decision. So getting into a bit more detail. So till now, what I've explained is like how we built our AI reviewer. But even though, so we did not want our review process to be completely autonomous. We wanted, we basically wanted to have a human in the loop approach. So then what did we do? So all papers were initially reviewed by 3 independent AI reviewers. So this is where you see these 3 frontier models come into picture. So each AI reviewer is basically using one of these frontier models, Opus, GPT, and DeepSeek. Then once all the papers are reviewed by these 3 AI reviewers, we filter out or reject or remove all papers which are basically marked reject by all the 3 AI reviewers. So again, before I explain more about this AI review process, what I would like to mention is we are not at all claiming like this is the only way to do human in the loop, human plus AI review, or this is the right way. I think this is one of the ways which we tried. And in fact, Dhruv and I have plans to basically try out some other approaches after this conference and then see which one fares well. And you will see, different conferences like Newer IPS, ICML, they are also trying to introduce some kind of AI reviewing in the process. So it's still, the process is going to evolve. So we also took a shot at it, and not at all claiming like this is the right way. This is one of the ways which we thought could be useful. So we filtered out the papers which were marked as reject by all three AI reviewers. So this was kind of a proxy of removing the papers which were not satisfying the minimal acceptance bar. Again, not saying this is going to be perfect, and obviously there would be some errors, and I mean there are always some errors in the review process, in the current review process. And then, of course, once we had filtered out these papers, remaining ones were papers which were essentially having papers which received mixed decisions from the three AI reviewers. So, for example, two AI reviewers have marked accept, and one AI reviewer has marked reject, or two AI reviewers have marked reject, and one AI reviewer has marked accept. So in this case, uh, we we also allocated a human expert, a human reviewer to each of these papers, right? So right, and of course I'll come back to this, like how these papers were finally evaluated, and then papers which were unanimously accepted by all three AI reviewers, they were directly reviewed by the PC chairs. So PC chairs kind of acted as a meta review. So the area chair kind of role which the large conferences has, PC chairs played that role, and uh, went through the paper reviews and then made a decision whether this paper requires further human review or not. So a portion of these papers were further marked for one independent human review. And ultimately, at the end, once we had basically AI reviews plus human reviews for all of these papers, which were not rejected initially, PC chairs took a look at all the took a look at each paper and the corresponding AI reviews plus the human review to take the final decision. So all in all, the initial, you can say in simple words, the initial reviewing was done by AI reviews and AI reviewers, and this information was used as additional piece of information and handed over to the PC chairs for making the final decision. So ultimately, the final decision was taken by the PC chairs, which are the human experts, basically. So now this is an interesting slide, I think, for all of us. So what we did in our submission process, as Paras mentioned initially, that not almost everyone, but you can say a considerable number of researchers are using AI in all across the research process, whether it is hypothesis generation, evaluating, doing experiments, doing analysis, writing the paper, etc., etc. But nobody is explicitly declaring it because obviously the conference policies don't allow it, right? So, but we did, since we had this our agenda or our thesis was that we should explicitly ask allow usage of AI. So we had this AI involvement checklist, which every paper had to submit, which every author had to submit. So there we essentially asked how much was AI involved in every step of the research process. So we had broadly divided the research process into four parts: hypothesis development, experiment design and implementation, analysis and interpretation, and writing. So we asked, for each of these stages of research, the authors were asked to choose an option among these four options. So whether the stage was majorly done by humans or completely done by humans, or majority by humans with some AI assistance, majority by AI with some human assistance, or completely by AI. Right. So as you can see on the left hand side, we have numbers splits for the accepted papers and the rejected papers, and you can see, I think, a good number of papers have basically marked that they had used AI assistance. So category B and category C is basically the major category. So mostly human plus some AI help, or mostly AI plus some human help, right? And you can also see that there is not much difference between the AI involvement in the accepted papers and the rejected papers. So there's not much difference. Now let's take a look at the second graph on the right hand side, second set of statistics. So here we additionally asked for each category, how much did the authors work with AI to get to the final result? Because it's not like, obviously you can do zero shot generation as well, but generally I think most of us, when we work with Cloud Code, Codex, etc., we keep giving feedback to Cloud Code, Codex, and then and then when we are satisfied with the final result, then we go ahead with to the next step or the next stage, right? So we also asked how many attempts did the authors make in every stage while working with AI. So again, we had like three categories here. Low, that means they did not had to work too much with AI. Once the AI gave the output, they were satisfied or they directly used the output. Then second category was medium, right? So 10 to 100 iterations, 10 to 100 attempts. High was, of course, a lot of iteration with the AI. So here again, you can see the stats for both accepted and rejected papers. And here again, I think the medium and the high ones are kind of uh, uh, occupying
Recording
the most,
in progress.
uh, majority of the papers. Here, I think there's one specific insight I think which Dhruv mentioned earlier today, that you can see, for example, in accepted papers, for example, we have 60% of the papers saying that they had to spend a lot of time with AI, iterating over the design, the evaluation, etc. And then rejected papers, or the high number of papers citing high involvement or high effort with AI is 42%. So that's slightly on the lower side. I mean, this is like you can see some kind of marker which is kind of saying that if you work more with AI, I mean, if you get involved with AI, work together with AI, go through multiple attempts, multiple iterations, I think the quality may be slightly better. I mean, these are not like, of course, concrete or conclusive results, but shows some significance, gives some hint about the quality of paper and its correlation with the AI involvement. So moving on, so I think this is again a very important slide to discuss. So what were our learnings, high-level learnings from the AI-assisted review process and reading through so many papers which were declared as written by AI or declared as a lot of assistance was taken by the authors so they wrote the papers with the help of AI. So in the review process, I think in general what we found, and I'm sure many of you would agree, that AI reviewers are good for, I mean, doing the initial checks, like are there any obvious inconsistencies? Are your references actually real or are they hallucinated? Have you missed out on certain very obviously related research papers which you should cite in your paper? Are you overclaiming? Are you is your evaluation comprehensive enough? Are you missing out on some ablation? So I think AI reviews are generally good at flagging what's missing in the paper or what's probably wrong in the paper, right? But what they're not good at is, so what I think in one word, if you could describe, they're not good at having this research taste. They're not good at validating whether the idea is novel enough or not, or impactful enough or not. They're not good at essentially judging how good the results are. Many times you must have seen, at least we have seen in our review process and going through these papers, the numbers are not at all interesting enough, yet the reviewer is kind of going ahead with whatever the authors are saying, right? And many times, again, this was also an interesting insight, that as long as the authors in the paper add something um, in the limitation, the AI reviewer doesn't count it against the paper. So obviously, it's a good thing to add limitations in the paper, but if everything is added in the limitation and the paper is not doing anything, obviously you can't accept that paper, right? So AI reviewers are not good at making this distinction between, I mean, how to balance between the explicit declaration of limitations and the actual value of the paper. Obviously, they were not good at making the final accept reject decision. And of course, they're not perfect at interpreting the figures, graphs, and catching the inconsistencies between the graphs and the text and so on. On the paper side, the AI written papers or papers which were written with the help of AI, I think very frankly, went through a lot of papers, very difficult to read. These AI written papers, if you're not, if as a human expert you don't know how to write papers, the first draft which the AI written papers, AI systems generate, it's very difficult to read. A lot of technical jargon, lot of numbers, very dense in content. In fact, some of the human expert reviews which we received and which we went through for some of our papers, one of the comments was the paper is completely incomprehensible, not at all able to understand what is there in the paper. This is what we call, as you can say, is one kind of AI slop, which is actually hitting the research community recently. So I think this is something which we also need to learn. I think we'll talk about the lessons a bit more later on, but I think you need to know what a good paper looks like, right? In order to be, at least at the current stage, you need to know what a good paper looks like in order to get that paper out of the AI systems. You can't just rely on them completely. Other failure mode was figures, graphs. Many of the papers had not so well formatted or visually appealing figures and graphs. Of course, someone would argue, why is that important? I think in terms of readability in research, if you hear the great researchers anywhere, I think almost everyone would say presentation is almost or even more important than the actual work which you've done. So having nicely formatted figures, graphs, the overall paper should look good and should be easy to read. The other thing I think we noticed in our AI submitted AI written papers was that, as I mentioned, these AI systems are not good at identifying or making a decision of what is a good problem. So many of the papers were around problems which were not so uh, uh, well motivated or close to the real world, and this, of course, we can, as I mentioned, I think AI is not good at making that decision. Is this a good problem to work or not? And I think Paras also mentioned in the initial few minutes of this session that eventually we'll probably move to, the world is gradually moving to a scenario or situation place where we don't need to execute the research process step by step, but the human experts need to decide what are the good problems to work on, define the problem statement, formulate it, and so on. So these are some of the lessons, right? And of course, I think, uh, so we had the most interesting part about the conference was we were able to get our support from API credit support from Anthropic, OpenAI, and Jarvis Labs. And as part of that, we have selected 3 papers. Each of these papers will be getting some API credits from each of these providers. So congratulations to all these papers and the authors associated with these papers. So in track 1, we chose one paper titled A Forced Structure Reduction in Verifiable Bounds for Conway's 99 Graph, authored by Alok Thakkar, a solo author. And in track 2, we chose 2 papers. One was on how model scale and layer geometry invert the meaning of internal disagreement in LLMs. And then second one was activation oracles. Can we use activation oracles to detect sandbagging in large language models? So congratulations to all the authors, Alok Thakkar, Devjyoti, Arjit, Parth, Prateek, and Divi. We will reach out to them separately as to how they can get access to these credits, of course. So I think concluding, I think all accepted work will be listed publicly on our website. And so I forgot to mention this, our conference, we allowed both types of submissions, archival and non-archival. For archival papers, we will also publish them through the open review portals. All the papers will be accessible through the open review website. For non-archival ones, the papers will still be accessible via our conference website. I think this is the first time we're having this conference, so somehow we couldn't have poster session or even in-person session for this conference. But still we'll give all authors of the accepted papers a chance to submit a poster, which we can display on our conference website. And this goes without saying, all the sessions, recordings, everything will be posted online. Dhruv T is doing a great job at that. And I think, yeah, this, as I said, this is the first attempt at this conference. Almost all of us, Dhruv T, Paras, Professor Murari Mandal, myself, I think we'll sit together and discuss and revisit this and see how do we want to take this conference ahead. Since this is a new conference, I think we can do more experiments. Maybe next year, the conference design will be completely different. Who knows? Yeah, so that's it. I think now I'll hand it over to Dhruv T for just concluding the session.
Thanks, Professor Kumar. That was lovely. And yeah, like just doubling down on what he said, right? Like for all we know, next year when we do this, or when we do this in the future, we barely have human authors, and it's actually just a conference for AI scientists, and we don't even necessarily need to be involved. So yeah, exciting stuff. Before we sort of open the floor up for questions, since I see there's a lot of discussion, I did want to point out that, like Paras said earlier, one of the main goals that we had here was also to draw attention to the changing paradigm of how we do science. And this is why we've been organizing sessions and workshops all throughout, even before the submissions closed, as well as since early this week. We do have 3 main sessions that are still lined up, starting from today until Sunday morning. The first one is the scientific method in the age of AI, where we'll be joined by Professor Chen Hao Tan from Chicago and Dr. Federico Bianchi from Together AI. They're going to be in conversation with John Bohannon, who's an ex-science journalist, talking about how each stage of the scientific method is changing. It's going to be a great discussion. We're going to talk about future of science communication to double down on how should folks be communicating results, or how do we see the future of the research infrastructure develop? Because perhaps, like Paras and Professor Kumar also mentioned, archive and conferences are becoming a bit dated, and they are being inundated with large quantities, which they're not able to handle. So a little bit of discussion on new formats for that. And then Sunday, we will be talking with Dr. Shiv Kumar from ANRF, and Vishnu, who's the founder of Jarvis Labs, along with Pranav, who's an ex-investor from Lightspeed and now a builder, about what does it take for you to build sovereign capability for AI for science. We think this is particularly topical, especially since we saw like everything that went down with Fable coming out, and the conversation around access to it since then. So yeah, dropping the Luma link. I'm hoping most of the folks who joined this session have already registered for these ones, but if you haven't, please do check out these sessions as well. And I think with that, we might be open to questions. Professor Kumar, do you want to lead with it? I think there's a bunch in the chat. We can also just welcome more.
Yeah. So should we go through the questions in the chat?
I think even one of the, we can go, I just noticed some discussions, we can pick up themes and verbalize and open for a discussion there. I think one of the theme, I mean, at least the one that I picked up on taste, and I mean, what is taste and how do you judge taste, right? And I think that's an interesting question. And as I said on the chat, it's very hard to define what taste is. And in fact, I think a lot of what we see as taste in humans generally end up being a selection bias also, in the sense there are like 1,000 people trying to make a movie and one movie becomes successful. We end up interviewing that one successful director on how do you make great movies. I think taste is very hard to codify, and whatever is hard to codify, we end up saying that. Having said that, I think LLMs are picking up a lot of latent factors and dynamics on how humans decide. So some of the early research, I think literally we were discussing at Lossfunk that these LLMs have become really good at predicting, let's say, the outcomes of social experiments with a correlation factor of 0.8 and above. And these LLMs have become super forecasters, which are neck to neck with the best forecasters in the world. So in the sense of their ability to predict these aggregate dynamics in any domain, I think I personally don't have any doubt that quote unquote taste will be out of bounds for them. I think it's just a matter of how we define it. So a lot of trick is into, I think, prompting the models and navigating them to getting them to do what they want to do, because by themselves they're just like a passive phenomena. So I think one analogy that I really liked was the river and the bank analogy. Like, what is a river without a bank? So in that sense, LLM is like a river, and the bank is the constraints that humans set on it, right? So and I think given the right prompt, they will have really good taste also. Dhruv, Professor Kumar, do you have any comments or?
Yeah, I mean, just noted in the chat that we had of course, my personal, I fully second this bit that I was just telling folks at Lossfunk also that earlier we didn't really understand intelligence and we built proxies to measure it, but now we have a better notion of it. So we've just moved like a level of abstraction up on what is undefined, and we use it, like you said in chat as well, as a catch-all for what is missing. Right. So it's hard to codify taste. So now we say LLMs lack taste, but we're sure they're intelligent now. Right. But also, I did want to point out, like, we had Dr. Amber Lou from Michigan with us earlier this week, and she said something very interesting, which I sort of strongly resonate with as well, which is that one way to codify taste in models like these, especially for automated science, is to think about it as resource allocation. Because even in human researchers, what we think of as taste is really just how much time or how much human effort, let's say, you're allocating towards different problem spaces. So even if we can train these models to become really well at just predicting what path of scientific discovery to allocate more resources to, like we would eventually start qualifying them as having better taste. So yeah, that was a good proxy for me. Yeah, but Professor Kumar, I think there's folks in the comments also. So yeah, we can hear you.
Yeah, agree. I think generally agree with both Paras and Rutti. They have selection. I mean, research taste also has the selection bias issue, and I think models are definitely evolving. So the taste, I think they would catch that taste as time evolves. So I'm also generally positive. I mean, yeah, let's see if we can. And I think, as Paras mentioned, if we can actually, so I mean, that's what is happening today, right? I mean, if you are a domain expert, if you are a research expert, if you are a good researcher already, you know what a good paper looks like. You can actually make the model write a good paper. It's not that model cannot write the good paper. You just have to do a bit more prompting, etc. I think what people call as build having those skill files, right? So I mean, yeah, I'm personally also doing that at my own lab, and I'm sure Paras, etc. are also doing it. We have a set of instructions for the model, and then if they try to stick it, we obviously see a better quality writing and even better selection of ideas and so on. Yeah, so generally agree.
And I mean, one last thing before, let's say, we invite some audience folks to say as well, right? Like, since we do have a verifiable track, and I think this is also something we've discussed at Lossfunk enough, which is that in the case of, let's say, verifiable problems, especially problems which are like cheap to execute in terms of compute and time, you really do not need to even question the taste, because you could possibly just run variations, right? And actually just pick the best variation. So any problem that can be made verifiable loses a certain amount of limitations of, let's say, research taste, because then you can just like actually run all possible variations. So yeah, that's very exciting as well. Yeah, sorry.
I mean, just maybe last comment. I think on taste, good taste in science, I think has such a long feedback cycle that it can. I mean, when there are people like Boltzmann whose ideas were never recognized in their lifetime, who had to kill themselves because they thought that probably they're crazy for proposing it, and after like decades after their death, their ideas. And I think history is just full of people who have really sort of languished in their lifetime, and their ideas caught on later on. I mean, and how do you predict that? Even humans cannot predict that, right? Throughout our history, the whole scientific enterprise has not been able to recognize great ideas immediately when they come. So the target itself is high variance and moving. So I think expecting like LLMs to be great at something that humans also don't have a great consensus on. If you ask three people what is a better paper, they will also, I mean, the whole point of these conferences with high variance of reviews is that humans themselves don't agree what's a good paper. So net, I don't think like it's a very useful term also to think about, but I don't know an alternative. If you're talking about open problems, verifiable, great, you're making progress or not. But what is good science when you have just no grounding at all? I think it's much more philosophically interesting question. Yeah, maybe we
agree. I think
folks
very interesting point, Paras. Yeah, let's open the floor for questions from folks. Let's see.
So does anyone have a burning question? Feel free to unmute and.
I mean, since no one's unmuting, Vidit has one in the chat, and then we can perhaps take Aditya's after. Yeah.
Sure. So shall I go ahead?
Yeah.
Okay. So my question was, in present AI conferences, right? Do you think there are some agentic workflows that they use or something to evaluate the papers? Because right now I'm seeing on X, and the backlash that NeurIPS is getting is like crazy, just because reviewers are using AI, people are using AI, and they're like, oh, they're blaming the reviewers, the reviewers are blaming the people. It's a shit show, right? So I want to know, is there AI being integrated in these conferences? Are the people who are handling these conferences starting to think about it or something?
So maybe let me answer a couple of things, maybe then Paras can also speak. So see, there are three things. One is, I think conference organizers, everyone is taking note of this, what we are also taking notes. And other thing is these big conferences, obviously you can't change them overnight, right? So they are trying out experiments around AI-based reviewing, AI being involved in writing, AI being involved in reviewing. In fact, ICML, I think Dhruv just listed a link for paper assistance too. And one thing which almost everyone is agreeing is that you can at least take some early feedback from these AI reviewing systems, right? So that almost everyone is agreeing. And NeurIPS, ICML, many of the conferences have already started integrating. Then second thing is that about like why reviewers are using these agentic workflows. So that is again, there also I think these conferences are trying out different experiments, like splitting the entire review process into two parts. One part where kind of A/B testing, one part where they allow the human reviewers to use AI to do the reviewing, to take help of AI. Second part where they explicitly ask the reviewers not to use AI for reviewing, right? Again, see, I mean, there's no way we can actually check or verify whether the human review used AI or not. And everyone is kind of, you can say, many of the researchers are overloaded, they don't have time, or they want to take shortcuts. That's like common human psychology. So people are still using these AI agents, even though the conference is not asking them to do. Right? So I think there's a mix of all of these things. People are taking note. I was just having this conversation with Professor Murari today morning, and we were confident that I think in a period of 1 to 2 years, I think we'll see major changes in the conference reviewing style, and we will see some solutions also coming up. They may not be perfect solutions, but some things will happen. Yeah. Paras, if you want to add.
Yeah, I mean, I was just saying, I think we should expect humans will be humans. So I think default expectation is that everyone is using AI, both for writing papers and review papers. It's just human nature to save effort. Yeah, I mean, we should just expect AI to do most of the cognitive labor and humans to do review. I mean, we may not like it, we may not think it's morally correct, but like Professor Dhruv Kumar said, if everyone is super overloaded, tons of priorities, that is going to happen when you have 40,000-50,000 submissions in this conference. I think the current format is unsustainable. It was never meant what's happening.
Yeah, I have a question. Today, it's very nice, for me to see that, AI is able to generate papers and, we can do things. But this seems to be an easy way of generating, easier, convenient way. Yes, there are difficulties, there's a cost involved in it. But over time, will this be the model of, how people are going to generate white papers? They will not come with the fundamental white papers. That's one question. The second question is that's also, because this is happening in India and Bangalore. Typically, when I talk to, I used to come with a science background, and I have people who are professors in colleges. They say no one joins physics and math. Everyone joins some computer, cyber security or something, anything and everything with computers. So the fundamental, if you look at Anthropic or anything, the fundamentals are calculus and physics and a lot of things. These things are the AI things. Are we going to lose them? This is just when I hold two thoughts together. One thought is it's exciting to see that something can create wonderful, but on the other side, I'm also holding that thought. I don't know. I'm sure others have thought about it. Thank you.
Paras, you want to answer?
Yeah, I mean, of course, I think it's. You've just described what's happening, and I don't think it's two ways to think about it. One is follow the economic incentives. And people respond very strongly to economic incentives. And that's why everyone is shifting from hard sciences to ML, etc. But I think the economics will adjust. I do think there is an oversupply of ML and AI engineers, especially AI is automating AI engineers, AI researchers' jobs the first. But having said that, I think the basic curiosity is an individual's responsibility, and you really can't delegate understanding, right? So if you're doing research for joy and you're using AI as like a oracle for generating papers, it's like a pointless activity. Uh, and if someone is doing that, good for them. But what's the point? I mean, if you're genuinely truth-seeking, curious person, I think you'll very quickly self-adjust and rely on AI less and less for basic understanding, and more for just a grunt work. At least that's what I've done. I've personally gone back to writing code in IDE, and less just that black box kind of a thing. So do you care for outcomes? Do you care for understanding? I think that's a question that each individual has to answer themselves.
And if I might just add also, because I mean, we were just talking about this also. I do think that another thing that this will enable us to do is also just relook at some of these domains and like what we hold in high regard in those domains versus what is actually tough, right? So that's going to be exciting as well. Because, for example, we were speaking with Dr. Manmeet Singh, who's working in energy sciences and earth sciences yesterday, right? And as it turns out, those happen to be domains that are more complex and less pliable for AI automation. And it's not like all parts of math is also like super easy to do. We know like the coming up with problems bit is where folks, the models still struggle. So in that sense, like I feel like I don't think any of this is going to go away, like, but I think we'll just reorient our focus on what is actually useful for humans to understand versus, let's say, what outcomes we can just generate with sort of automated science, because the outcomes is what is valuable there. So, yeah.
But I think the future does belong to people who will retain agency and not just delegate it blindly to black box systems, because everyone is doing the same, and basic economics will sort of show it heads again, right? If everyone is using the same systems, then you have no edge over others. An edge will belong to people who take a more nuanced approach in any domain, right? And who feel they can make a difference. So let's see.
And yeah, of course, I think a very important lesson for students as well here. I think we can use AI for the grunt work, but we should never forget that having a strong foundation grasp on the fundamentals is all the more important these days. And so we should use AI, but use it intelligently.
One additional question to Dhruv Kumar is, you said that people were not writing white papers, they didn't have experience, and someone is starting with AI agents and, trying to come with a white paper, they will not have experience. Are you guys, as a professor, are you guys trying to help people, who can write white papers? That was a curious question. I used to write white papers. I know people writing white papers. So I thought, is there something like that planned also from a positive side?
So if I understood your question correctly, are you asking like, are we helping our students how to teach them how to write papers? Is that the question?
People only in the colleges, so the professors could help. That's how I learned maybe 25, 30 years back. My prof, and everyone bet me out, grilled me to, write good white papers. But today, you are sitting at home, you have built up great logic, and now you have to put a white paper. I did a great logic. I did something really astounding. But when I'm putting, as you said, if you can't understand the paper, you cannot, review it. So, so there's a gap between, though in this whole optimization of the beautiful thing, we create a gap for the starting student, not for someone who has already done it. Someone who has already done published white papers will find it easier to publish white papers. But for someone who is new to white papers, how will he build that muscle?
Right. So I think it's a gradual learning process. Yeah, definitely it's a gradual learning process, and we do teach that process. At least I do that. I teach a couple of courses here at BITS Pilani, and for any advanced course, any graduate level course, I think the major component of the course is working on a course project where with the final deliverable is kind of white paper or research paper, whatever you want to call it as. And I spend considerable time with each team, at least 3 to 4 rounds of reviews with each team to make sure that the final deliverable is something which we can submit it to a workshop or a conference. So I think, yeah, there is definitely some training and learning required at the moment. We do spend time. Again, I'm also using a mix of both AI based training, doing some initial reviews using AI, handing it over to the students, and of course the nuances and the things which are not fixed by AI, then I take over and then give that feedback. I think Paras is also doing something similar at Lossfunk. They're trying to build tools and around this training students as to how to do high quality research and so on.
Yeah, but on writing specifically, I think we make sure at Lossfunk the first draft is not LLM written.
Okay.
First draft has to be human written, because otherwise, whatever LLM spits out, it biases thinking so much, and obviously it's AI written, and humans are able to detect it, and they get disinterested in it. So, I mean, writing is to a large extent thinking. So, in that sense,
Yes.
ultimately, it's individuals' job and responsibility. But I keep reiterating that first draft you have to write. You can ask for grammar feedback and structure feedback, but if you just delegate writing, then I don't know, like, what's the point?
Makes sense. Yeah, so similar only. I think I have like a list of questions which I ask students to write manually, and then use to basically build the entire context, answer everything related to the research paper. Then you can maybe use AI to do the initial bit of writing. Yeah, similar, but I think Paras is more Paras approach is more human first, AI later.
Traditional.
Yeah.
Yeah, we have a question from Samarth.
Yeah, and I think Samarth, since we're on time, this is also going to be the last question. So, you have the floor. Yeah.
Sure, perfect. I hope I'm audible. Perfect. First of all, thanks a lot, Dhruv sir, Paras sir, and Dhruv, for this wonderful, first of all, wonderful initiative and wonderful presentation. And great to see you, Dhruv sir, after a long time. I have a few questions regarding this concept of using AI scientists as reviewers, and also I'll just take some instances from the slides that were mentioned. 3 concrete questions. I'll make it very quick. First of all, I think the first questions come from one of my previous works. Is that how, like, did you guys also check the prompt injection techniques that are being used these days? Because I feel that creates a lot of bias. And one thing which I want to note is specifically about the fabricated priors that we notice in our work, which is basically that if you say the model, like if you convey to the model that like you have to review this thing, but there is another reviewer who has reviewed your work and he has given you a 2 out of 10, and versus the reviewer has given you a 9 out of 10. That really changed a lot of things in our cases, and it was so prominent that we also saw a shift of scores which were like 2-3 magnitudes on a scale of 10, which I feel is a bit prominent in these kinds of competitive scenarios. The second question is, I think one major question that really came into my mind when I saw about this conference was that how do we are going to make sure that how we're going to verify the things that are being said in the paper. So like trying to distinguish between the plausible looking and the actually sound research that is being done, because I feel that I think I missed that part, that how the verification of the claims that were there were done. So coming to that question, because I think the complete aim of this AI as a scientist is to, I think everyone is working with the final goal of advancing science using AI. So I feel that it should not only be a good looking paper, but actually something that contributes meaningfully, which really needs to be verified very properly, which I think there's a lot of debate about using AI slop in all these conferences that are going on otherwise. My third question is, I think this is also flagged in one of the slides, which was about the novelty issue, and which I really believe also in my experience as well, where it's a bit difficult to find the novelty and the trying to trace it to what the work has already been done, which I feel that LLM still if I think I would still trust a manual check of the related work done than a LLM given summary of the related work done. So I feel that that's the third question regarding novelty. How was the novelty checked in this process? Which I would love to connect that to the broader picture of using AI scientists as research collaborators and also as reviewers in these conferences.
So maybe I'll answer them briefly one by one. So first question about prompt injection. So I think that's like the standard thing you do with any AI reviewer. The AI reviewer should first check whether there are any prompt injection attacks or similar attacks. Prompt injection is not the only attack nowadays. I think these attacks will keep on evolving. So that's the first check you always do while building the AI reviewer. I'm not sure whether Shashank we did this or not, but I am actually doing this for my own papers as well to make sure. Sometimes when you work with a number of collaborators, just to make sure that whatever we are submitting is clean and all that, right? And second thing about verification, I think very good question, Samar. So by verification, so think of it from this perspective, like if as a human reviewer, you are reading the paper, right? So what kind of verifications can you do, right? So one kind of verification is you can verify the novelty by looking at the existing work and then kind of make a like high level decision about whether the paper is novel enough or not. Other kind of verifiability is like methodology is saying that you used chat GPT or GPT 5.5 model and the evaluation is also using the same model, right? So this kind of basic verifiability claims can be checked. Third level of verifiability is if the paper has shared the code snippets and whether the code is essentially doing the same thing as what is basically mentioned in the paper, right? So we did all of these checks, right? But at the end of the day, we obviously did not reproduce the entire paper, right? So let's say the paper is saying 20% improvement by doing, let's say paper is proposing a new kind of KV cache and it is giving 20% improvement over the existing KV cache implementation. There is no way for us to essentially verify that without reproducing it. That's why I think reproducibility is becoming all the more important. So I would say in one line, if whatever a human reviewer can do without actually running the code and so on, I think that all we tried to do through our AI review. Having said that, I think someone had also asked about did the AI reviewer try to reproduce the paper? So answer is no, we didn't go in that depth. But I think Paras actually wanted us to do that, but due to resources, time constraints, etc., I think we could not come to that. But yeah, in the longer run, something like this would be useful to have. Third part about novelty. Yeah, broadly agree. I think that again goes on to, as Paras said, and we discussed, and we also see in the review process, right? 3 human reviewers, 2 will say it's novel enough, third one will say not novel enough. So I think it again boils down to research taste and so on. So it's very subjective, basically, what is novel, what is not novel. Someone may think the methodology has to be novel enough. Otherwise, very often we see in our papers that the reviewer is saying you just bolted 2-3 techniques together and did a new evaluation. So what's new in the paper? So I think different people have different kinds of definitions of novelty. So that's going to remain subjective. Humans don't agree, so we can't expect AI agents also to agree.
Got it. Just 2 quick follow-ups on this. So, like regarding the second point about reproducibility, do you think that it's also a good option or maybe a new thing of using AI as a reproducibility check? Bringing specific code-based agents to check this. So I think that's already mentioned by Paras. And the next point was being that regarding the novelty, also regarding the work that has been done recently about this. So is there a check also done on that, like regarding that kind of novelty that doesn't matches any other things that are being done in the past, and how reliable are they in their answering regarding the nearest work done to the work?
So for the first question, yeah, I think people are already moving in that direction. Paras shared a link, and AlphaCai, which is like the AI version of Archive, I think they are already kind of enabling this facility. See, reproducibility was always a thing which was discussed in these papers. In fact, so I did my PhD in systems actually. So there we had these reproducibility batches also. I don't know if AI conferences have this, but so there a separate committee used to sit for doing the reproducibility evaluation and so on. So I think reproducibility is something which can definitely be done to some extent, automated using AI. People are already moving in that direction. So what was the second question?
It was regarding trying to see what is the nearest work done to this and trying to see how does that differ. I think that kind of novelty.
So AI, in my personal experience and using AI is good at flagging, not all maybe, but a good chunk of related papers. But again, like what is new, what is novel enough, how do you sell your paper, how do you sell the story? I think all of these things are very subjective.
Got it. Thank you so much, sir. Thanks a lot for that.
Yeah.
Should we wrap up?
Yeah, let's wrap up.
Sorted. Thanks a lot. Thanks, folks. This was lovely. Thanks for the engagement as well. Thanks for your questions, Samarth, and everybody who was engaging in the chat. This was lovely. This was the first time for us as well. So all the questions are very helpful feedback. Please do stay in touch if you're interested in this automated science discourse. Submit to the next version, and please attend the follow-on 3 sessions tonight at 9:30 on the AI and scientific method, and then tomorrow at 9:30 again, and day after morning. Thanks a lot for joining in. Have a great night ahead.
Thank you, everyone. Thanks.
Thank you, guys.